this was the one in part A here that some of you had noticed, well, that's really goofy because it wasn't really standing out in your packet. You had a bad copy. And so some of you didn't realize that there was a -2 up here. But that's what we're going to do today. I mean, we want to keep organized. And remember, math is about logically using stuff that you've already learned for new material. So if we're going to talk about subtraction today, the definition of subtraction is to add a negative. If we do that, I mean, if we saw this problem and it said x plus 1 over x minus 1 minus 2 over x squared minus x, the best thing to do, so we don't lose track of that negative, is switch it to this. Because we know we're going to have to distribute that -2 in order to get ourselves a common denominator that's going to work for this problem. So really, we're not learning anything new today as far as that goes, but we are going to experience what are called complex fractions today. And that'll be a new piece that's a little bit different for you. So we are on problem 3, which is subtracting rational expressions. And it says, what is the difference of the two rational expressions in simplest form? And state any restrictions on the variable. So we have one new step. We're going to change this to adding a negative. Which in this case will mean distributing that negative to both of those terms that we see up there. So that'll be a -x minus 2. Now normally I don't do that as, one step on its own. I would probably do the factoring of the other terms while I'm there. But that's really important when we're talking about subtraction so that we can keep track of everything. So now we've got our nice little x plus 2 on the top here, but I haven't factored, so I can't talk about restrictions. So x squared minus 2x, what would we factor out? Just take an x, yeah, greatest common factor. And how about 2 times x minus 4?
-1. A 2.
Not the numerator. The numerator's going to stay that way.
2.
Yeah. He was looking at the numerator. It happens, there's a lot to keep track of. So right now, let's talk about LCD. What's going to have to be part of our LCD? Got to have a 2. The numbers have to be there. Do we have any stray variables? Got to have an x. Any factors? All of it has to be there. Do we have any power of x minus 2 that's greater than 1?
No.
Then we're good. All right, so now what do we do? Well, we're going to stop and talk about domain restrictions before we get ahead of ourselves too much here. So if that is our LCD, what's out? 0 and 2. So those two numbers cannot be used. Well, let's build them up. What does the first one need? Just needs a 2. What's the second one going to need? An x. I'm going to try and put that in here because I really like distributing from the left better than distributing from the right. So that's what we'll need. Alrighty, well that will give us 2x plus 4, but only distribute it in the numerator. Don't distribute it in the bottom. Just write it as 2x times x minus 2. We want to see that common denominator when we try to put these two together. X times -x minus 2 will be -x squared minus 2x over 2x times the quantity x minus 2. We can see the common denominator. There it is. And we can double check. Yep, 0 and 2, those are the two numbers we would not want to use. Now, let's see what kind of a mess we have now that we can actually do that addition. Well, we have a -x squared back there. 2x minus 2x. That's kind of nice. It's gone. Plus 4 over 2x times x minus 2. Again, no new restrictions on the domain. If we did our job right with the LCD, we should be done with that part. But we might not be done with this problem. Because last step when we add and subtract is to factor the numerator and see is there anything we can cancel. Now Eli was a little ahead of the game. He said let's get that -1 out of there.
Dad, you like. Yes,
And x squared minus 4 does factor into what?
x plus
difference of two squares, so x plus 2 and x minus 2. And the x minus 2 will cancel out. Now we don't need the 1, but we definitely need the negative. So negative and then parentheses x plus 2 over. And then we just have a little 2x in our denominator. But again, no new domain restrictions because we took care of that. We took care of that. All right. So basically, the only difference between what we did on Friday and what we're going to do today is changing it to adding a negative. But it does create, remember, that is the biggest mistake made in mathematics, is forgetting to distribute a negative. So you want to slow down a little bit. There's a lot of steps in this stuff. So for A, we've got x plus 3 over x minus 2 plus negative 6x plus 7. Changing that to adding a negative over x squared minus 3x plus 2. Not that there weren't enough steps before, but that needs to be our first step. Hey, I'm liking that this first one is kind of ready to go. But can you find any factors for x squared minus 3x plus 2? Negative 1 and negative 2. So let's talk LCD. Oh, I can't put it there, otherwise I won't be able to put these notes. I need notes for people. LCD, both of them? Is that it? No stray anything anywhere? No, because, I mean, this is a binomial right here. So x minus 1 times x minus 2, which means we're leaving what out of the domain?
1 and 2.
1 and 2, they're out. Got it. So what's the first fraction need? Looks like it's short. Okay, it needs an x minus 1. Well, I'm going to have to do a little FOIL up here so we can see what we have. X squared plus 3x minus 1x will be plus 2x minus 3. But the good news is there's our nice little common denominator now. So let's see what we have. Got an x squared up there. Plus 2x, but then we're adding a negative 6x, so that will be minus 4x. Negative 3 plus a positive 7, that will give us a 4. So the question is, can we keep going with this one? We can, can't we?
Yes.
In fact, that is a perfect square trinomial up there at the top. You can write it as x minus 2 times x minus 2 or x minus 2 squared. Oh, I think this class had decided we like them both written out better, right? Okay. Because then it's pretty easy to see your little x minus 2, at least one of them is out of there.
I drew a line.
Right there. Got it? Do you agree this isn't necessarily difficult, but it's a lot to keep track of?
Yes. Yeah. It's a lot of
Yep.
to write down.
It's just fractions, but boy are they kind of difficult looking fractions. Bless you. What's going to be our first step on B?
You gotta change the to a plus, and then you gotta put negative x.
Looks ugly. Well, we better do some factoring here so we can see what's going on. Good news is the first one is all set. Kind of a freebie. Do you have your factors already for x squared plus 6x plus 5? What are they?
5
1 and
and
5? Okay, so let me scroll down so I can give myself a little room to write the LCD and the domain restrictions. LCD.
X minus 5x plus 5x plus 1.
You made me think for a second I might have wrote it down wrong. This one was an x plus 5 when we started. And then this one is an x plus 1 and an x plus 5 when I factor it.
X plus 5 squared, x plus 1.
No. It's x plus 5.
X plus 5, x plus 1.
So domain restrictions. It's okay, it's a Monday morning, these things happen. Domain restrictions. -1, -5. All right, so the first one needs what? Well, let's see what happens when you squish that in there. X squared minus 1 over x plus 1 times x plus 5 plus negative x minus 3 over x plus 1 times x plus 5. Good to go? Let's add them. X squared minus x minus 4.
X minus 5.
Let's see if we can factor that and do a little cancel. Two numbers multiply to -4 and add to -1. Run through them all. -1, +4, +1 and -4, -2 and +2. We're going to get a -1 from any of those. We were done, but we have to check. Now, that's always the last thing you do is see whether or not you can do
It's always
any
worth
more.
a check.
There it is. There it is.
Always worth a check.
Oh, there are bad packets too. Some of these, the copying was horrible.
That's why.
So we're gonna miss some stuff. All right, was there a
Oh, I
part
see.
C to this?
No,
That was
it.
The board.
The difference of blah, blah, blah. All right, we did it.
we did
So
it.
now, technically, everything that we've done up to this point is stuff that you did in exponential. Probably have forgotten it because it's been a great while. But we have to learn a little something new. We have to. And the name of these fractions, it just kind of scares people away. But if you know how to deal with fractions, being called a complex fraction shouldn't scare you, okay? Because we do already know how to do this. We know the basics of fractions. So a complex fraction is a rational expression that has a fraction as both its numerator, denominator, or both. You know, it's a mix and match thing. So we're seeing fractions within fractions here. Definitely ACTs. They always put these on the ACTs. It's just one of those things. So when you look at this, don't be scared. What you want to do is think, if I can just get this to be one fraction and this to be one fraction, then I can multiply by the reciprocal. So if I focus on getting a common denominator up here in my numerator, I can put those two together. And then this is already one fraction, so I'll just flip it and I'll multiply. We just use the strategies that we already know about fractions. This one's good to go. So what if it has a fraction in the numerator and the denominator? It's division. We can flip it and we can multiply. It's not a big deal. But the last one, the problem we just did, this is doing that twice and then multiplying by the reciprocal. So this is a little bit of a monster here. Again, not difficult, a lot to keep track of. It is not a tough process, it's just a lot to keep track of. So here's what we're going to do. We are going to use this the same way we've done all of this, which is let's get one fraction on the top, find common denominators, get everything together, get one fraction on the bottom, multiply by the reciprocal, because that's what we already know how to do. However, when we get to pre-calculus, we're gonna simplify a complex fraction by multiplying the numerator and the denominator by the LCD of all the rational expressions. What that does is it eliminates two of the fractions. So it'll get it down to one fraction right away. But we're gonna hang on to that until pre-calculus. So we can also simplify by simplifying the numerator, which is what we would do using the instincts that we have already in algebra, simplifying the denominator, and then multiplying by the reciprocal. So, look at this one, huh? Simplifying a complex fraction. I always love the way they say that. Let's make this simpler. What is a simpler form of this complex fraction? Well, there's the big fraction line. That means I need to come up with one fraction to represent 1 over x plus x over y, and one fraction to represent 1 over y plus 1, and then I'll multiply by the reciprocal. So you do this in steps. Well, let me get working with 1 over x plus x over y. The other part that's really cute is notice they're not having us give restrictions on the domain anymore. They're like, this is enough. Don't worry about the restrictions on the domain. We'll take care of that another time. What's your LCD for these two? Just these two, x and y. So let's get a y on this one, and let's get an x on this one, and let's see what pops out. Well, that'll be y plus x squared, or x squared plus y, if we want to keep it in alphabetical order, over xy. That wasn't so hard. That's our new numerator right there. That's one fraction. Now we go back, change our focus. Now it's on 1 over y plus 1. But the first thing you want to do is remember it's easier to work with fractions if everything is a fraction. So write that 1 as 1 over 1. And now look for your LCD. In the green up there, what's my new LCD? Y. Just y, which is great because the first one has one already. Just this one, I'm going to need a y on the top and the bottom. So we'll get 1 plus y, and that bothers me. I'm going to write it as y plus 1 over y. Now, one fraction. Let's write it. Let's see what we have. Right now we have x squared plus y over xy. Big fraction line. Parentheses there so you can see, hey, that's one fraction. And on the bottom, y plus 1 over y. Those first two steps, incredibly important, because now we can see, hey, this is just division. And you don't divide fractions, you multiply by the reciprocal. So this will be x squared plus y over xy times y over y plus 1. And now we look to see if we can cancel any. Because when we get to that multiplying bit, that's what we want to do. But we might be able to factor. So we better stop and see. X squared plus y. Can we factor that? Nothing? Okay. Well, xy, obviously we can't. Y, we can't. Y plus 1. So the only thing we can do at this point is cancel what? One y out of the top and the bottom. And then fractions, it's always top times top, bottom times bottom. X squared plus y times 1 is just x squared plus y. And on the bottom we would have x times y plus 1. And we would be done. Because that factoring that we leave there shows we tried. You know, we tried to get this down as far as we possibly could. But it just wasn't working for us here. Now, I don't necessarily like that they skipped the restrictions on the domain part. So let's talk about our domains. Anywhere we had a denominator, there's going to be a restriction on the domain. So we go to our common denominator for the numerator. What can't happen? Can't be 0. How about for our denominator? Y can't be 0, already got it covered, right? Okay. Anything new pop up when we multiplied by the reciprocal? Absolutely. What's the new piece? Can't be negative 1. Like I said, they're not really going to have you do those. Sorry? Oh! And I put an X down. Thank you. I do understand what they're doing. They're saying this is tough enough to keep track of, so we don't want you thinking about those domain restrictions. But they don't necessarily give you that nicety on the ACT. On the ACT, they're going to expect that you can do both these. That you can simplify a complex fraction, and you can give them the restrictions on the domain. 4a doesn't look so bad, right? Doesn't look awful. You think you could do that one? Yeah. Okay, give it a try, and then I'll have you check in with Chicken Wing Noble Partner and see how things are going. I'll put the lights up here. Oh yeah, you guys can do that one. X squared y over x plus y. Now, B looks a little scary. It's a little scary. But here's what we're going to do. We're going to remember, all we have to do is get the numerator to be 1 fraction. We know how to do that. Then we'll get the denominator to be 1 fraction. We know how to do that too. And then we'll multiply by the reciprocal. Absolutely. So I'm going to have you talk me through it.
Okay.
Starting with the top. What are you thinking?
Multiply the left fraction by x plus 1 on top and bottom, and then multiply the right fraction by x, so that the denominator is the same.
Sounds like a great plan, Eli.
That way, Eli. Yeah. Let's hear it.
Let's hear it.
Alrighty, so let's see what we get, huh? X squared minus x minus 2. Ooh. Kind of sloppy. Far so good. So now what?
Add the new.
Yeah, actually do the addition. You know, don't forget that part. We want this to be 1 fraction. So done? That's our numerator? Yeah, maybe not. Maybe not. We might be able to factor this into something useful, huh? Find a couple that work. This is a, you gotta be kidding me moment.
Bummer.
Yeah.
Bummer.
But this is now all ready for when we multiply by the reciprocal. So that wasn't a waste of time, but let's mark this because that is our numerator. Definitely want to come back to that, Shaggy. All right. Now, down on the bottom. Ooh. What should be our first step on the bottom? Subtraction.
Plus negative.
Add a negative. What you thinking next? Now what? Yeah, actually do the addition. You know, we don't want to forget that. That's what we were going to do here, was add these two together. Done with that? Yes and no? What could we factor out of the numerator? A 2. Not going to help us do anything right now, but it might in the next step. Market denominator. Whew. Now what? Okay, so let me go get my red one. My red one was x plus 2, x minus 1 over x times x plus 1.
Wow. Yeah, organization.
What? Yeah, green one flipped, right? Be careful that you flip it. Whew. What'd you see? Consoling. So what would be the best way to write that?
X minus 1 squared over 2x.
That's all we had left down there? 2x? That's all we had left down there. There it is. But it's so much simpler looking. That's a good thing. We wanted to simplify a complex fraction. All right. So, 4, 3, 2, 1, 0 again. How you feel?
I hope we get like 3 problems on
Yeah.
Yeah.
There's
Yeah,
a lot of
let's get, like-
spots you could make mistakes, right?
I'm like a
Yeah,
2.
that's a confidence
Let's take
downer
it 25.
right there.
I think we only need like 1 of those.
Oh.
What?
That was yesterday.
Oh.
Oh!
That's actually a lot.
Yeah, that's
Oh!
Shove the. Wait, are they all like this?
No. Remember, we didn't do subtraction on Friday, so that's
That's
a lot of problems.
that would be a lot if they were complex fractions.
That'd be too much to
Complex
ask.
fractions.
I don't think 59 through 65 is necessary. I think that was an accident.
Oh, 22 to 29 are complex fractions, aren't they?
I don't think those
Oh,
are
they're
necessary.
easy
Like
ones.
You sure?
34.
They're easy ones. Take a look at them.
What do you consider easy?
Yeah. You're a math teacher.
29 is the only slightly challenging.
Well, then
Slight, not even anything close to what we just did.
better not be close.
Not even close.
We're gonna have some issues with it.
Yeah, and the rest of that is review at the
For
end.
the average
You know,
Joe,
65.
how long do you think this would take?
For me,
An hour and a half.
20 minutes.
No.
no way.
Yeah, look at them.
Dude,
You
no
need to
way.
see them.
It won't take, it'll take way more than 10 minutes.
Maybe 20 minutes to learn.
You need to
Yeah.
see them.
I'm saying a minimum 40
1,
minutes.
2, 3 of them already have one fraction in the numerator, one fraction in the denominator. So all you're going to do is multiply by the reciprocal. Sweet.
I need that.
That could be
Once
pretty
you
tough.
see them, you know,
That could be pretty tough.
Yeah,
you'll know.
That's tough stuff, multiplying.
Cool. We're just not doing it. Let's do it in one.
Once you see them, you won't be so scared.
Number 22.
Already shaking the boots.
Oh, jeez. You gotta flip them. That's